So, so in the previous class we have gone with a recursion. So what is the recursion? So recursion means repeat. So recursion means repeat. So which particular concept is been repeating? So for that particular a function used inside the program is been repeating. So that one we call it as recursion. So before that we have gone with so many programs. So we shall still continue for the next another 2 to 3 programs now. So for that now you see till now we have gone with GCD, LCM, Fibonacci series and multiplication. So now you come for the new program, that is prime numbers using recursion. So in today's class we will be discussing 3 programs regarding recursion. So recursion means any function which is calling by itself. So any function which call by itself is called as a recursion. Okay, so first you come for this prime numbers. So what is the concept of prime numbers? Any number which is divisible by 1 and itself. So divisible by 1 and itself. It's called as a prime number. So now you have to check whether the given number is prime or not. So for that we are going with a recursive function. So that is start with the main program now. So n, what is the n value? It is the number what you are going to give. So n, what is the n? It is the number to check for prime. So that is, it is the number to check for prime. Okay, so n. So now you go for the for loop. So you are starting with 1 and you are going up to range what? 1000. Okay, so from 1 to 1000, any number you have to check whether it is prime or not. So for that you are going with n is equal to 1, n less than or equal to 1000, keep on incrementing. So print all the prime numbers in the range. Okay, so now I call the function if check prime of n comma 2. So if is the condition, check prime. So check prime of n comma 2, that is we call it as calling function. So calling function is check prime of n comma 2, where what is n? N is a number to check whether it is prime or not, and 2 is the value. So what is this 2 value? So 2 means, first come for the definition of prime number. 2 is 2 conditions. So what is the 2? It is the 2 condition. First condition is, what are the definition of prime number? It should be divisible by 1 and it should be divisible by itself. So divisible by 1 is first condition, divisible by itself is second condition. That's why so many, how many are there? 2. So that's why we give it as if check prime of n comma 2. Okay, so print that particular number, print %d comma n. Okay, understood. So you can go like this also. So what this one will do, it is going to print all the values from 1 to 1000. So this program is going to print all the prime numbers from 1 to 1000. Okay, so if you want to check whether that number is a prime or not, so then you have to go for this particular code. So this particular code is used for checking. So this is used for checking a number is prime or not. So they enter the number. So now you check if the check prime of n comma 2. So you call the function, you will print whether it is a prime or not. So this one is this, but this what program we have written, this part, it is for giving the list of prime numbers in the range of 1 to 1000. So what are the prime numbers you have in range of 1 to 1000? So that you can see in the output here. So this is the output. So from 2 up to 997, it is printing all the numbers. So are you understanding this? So this program can be used for printing the range of prime numbers as well as for printing the range of prime numbers as well as for checking the prime number is prime or not. So for that particular purpose, we are going here. So this program will serve you for two conditions. So first condition is, first program is for printing the prime numbers from range. So what is the range you have given? From 1 to 1000. Okay. Or if you want to give a number and check it is a prime or not, then you can go with that red quoted syntax. So red quoted syntax, you can go there. So this part, what you have this is to insert a number and check whether it is a prime or not. But this part is for printing the range of prime numbers from 1 to 1000. Okay, so now we shall go with what this check prime is going to do. So calling function is inside the main, called function is outside the main. So called function, we are taking two values, one is n, the other one is d. So n is the input number and d is the value what you are going to take. So in order to check for prime number, the value will be always 2. So understand here, in order to check for prime number, the value of d will be always 2. So what is this 2? It is a condition. First condition is it should be divisible by itself, and second condition is it should be divisible by 1. That's why we are taking it as the value is n is equal to 2. Okay. So are you understanding this particular program? So this program will serve you for two purposes. So first purpose, what you have taken, it is for printing the prime numbers in the range. So what the program, now you see the output, it is printing the values from between 1 to 1000. So that's why we have given n is equal to 1, n less than or equal to 1000. Okay, so now you come for the check prime. So if now you see here, so if n double equals 1 and n divided by d double equals 0 and n is greater than 2. Okay, so if these conditions will return it as 0. Okay, so prime number, it will be written 0. Okay, if d is less than or equal to square root of n. So now you see it is the recursive called function. So it is recursive call. So what is a recursive call? The function calling itself, it's called as a recursive call. Understood? So function calling itself is called as a recursive call. Inside the check prime function, we are again, see here, inside the check prime function, here you are again calling the check prime function. A function which is calling its own function, we call it as recursive function. Understood? So this is recursive. So what are the conditions for checking the prime? If n double equals 1 or n mod d double equals 0 and it is greater than 2, it will return 0. If d is less than or equal to square root of n, now you go with a check prime of n comma plus plus d. So this is the function code what you have given. It is n comma plus plus d. So here it was n comma d and here it is taking it as n comma plus plus d. So what is this plus plus d? So you are going to pre-increment the value. So what is d value initially you are having? 2. So plus plus d will go with 3 value 3. So check n comma 2, check n comma 3, n comma 4, n comma 5, you keep on doing. Understood? So this is the program what you give for the checking the prime numbers. So kindly understand here, this check prime will go with two reasons. So first reason is printing all the prime numbers, in the given range. So what is the program you have written? It is for printing the prime numbers in the given range. What is the range you have given? The range is from 1 to 1000. Okay. So similarly, if you want to check a number is prime or not, that means you are inserting a number and you are checking whether it is prime or not. So for that particular purpose, you have to go with this particular red code. So first you have to input a number, that is enter the number and scanf %d. Next you go with check prime of n comma 2, same thing, check prime of n comma 2. So printf % is prime, else printf num %d is not prime. Okay, so this is the program. So you can go either with, if you are going with the second choice, then you have to remove these 3 lines. So if you are going to check whether the given number is prime or not, then you have to remove this for loop, if statement and printf. So remaining everything will remain same. Understood? So understood this particular program? Understood this prime number program? So you have to understand there are 2 reasons. So first, the program is for printing the prime numbers in given range. So printing the prime numbers in given range. So what is the range? Range is from 1 to 1000. Similarly, you can go with another case. So to check the number, whether it is prime or not. So checking the number for prime or not, you can go with this particular red code. So what I have given in red code, that you have to understand. So now you come for the next concept. So what is the next concept you are going with is, it is one of the recursion where we are going with a string function. So recursion with a string function. So first we have gone with what is this program? So program is to enter the string and reverse the string. So reverse the string using recursion. So enter the string and reverse the string using recursion. So what is this program is going for? It is reverse a string using recursion. So it's a program to reverse a string using recursion. Okay. So first is you start with a main. So inside main printf enter the characters. So once you read the character, enter the characters rev of 0. Okay. So now enter the characters. You have taken enter the characters and say is the program is correct? Yes, answer me. So what's wrong in this particular program? So now you see here in printf enter the characters, you are not gone with any scanf statement. Okay, so you have not gone with any scanf statement. So for that, so you have to go with so code. So what is the code? So you can go with scanf percentage, because I am going with the characters here. So scanf percentage comma. So you have to read a string. So read a string, you can go with us. Okay, next you go with a rev function. So inside the rev, you can call yes, or you can just call the rev function. So rev will be acting on this particular. You can go with a rev, or so I'm telling you, you can go with rev, or you can go with rev of yes. As what is the string we have taken? It is yes. So for the percent yes, comma yes. So you can go with rev or rev of yes. Okay. Now you come for the ref function. So what is the ref function should do? It should read each and every character from the string. So here you have taken enter the characters. So percentage, because I am going with a name. So name will go with a percentage comma yes. So now read each and every character. For that we have gone with char c is equal to get char. So char c is equal to get char means it is going to read each and every characters. So read each and every characters. If c not equal to slash n rev. So this is the code. Here you see rev is the called function. So this one we call it as called function, and here we call it as this one as recursive call. So this is the recursive call. That means we are calling a function rev in which is inside the function called rev only. So this is called as a recursive call. We are recursively, if c not equal to slash n, then you go with a rev. That we go with a recursive call, and that one will be printed here. Put char of c. So this is the program to reverse the string using recursion. So understood. So now you come for the next one. Next one is Ackermann's function. So Ackermann's function. So it is one of the function what you can use for the recursion purpose. So use for recursive function. It is well defined total computable function but not primitive recursive. So what the Ackermann's function will take? Ackermann of function means so calling function and call function will be there. A of x comma y. So a of x comma y is defined. So what is a of x comma y? If x is equal to 0, it is y plus 1. If y is equal to 0, you go with a of x minus 1 comma 1. If x and y both are not 0, so you go with this particular code. Understanding? So what I am telling, if x is Ackermann's function, it is a standard function used for integers. So integer x and y. So if x is equal to 0, you will return y plus 1. If y is equal to 0, you will return a of x minus 1 comma 1. If both are not 0, you have values, then you go with a of x minus 1 comma a of x comma y minus 1. So can you tell where is recursive function here? So in this Ackermann's function, can you tell where is recursive function? So in this Ackermann function, where is recursive call? Can you tell? So everywhere you are going with a calling function and call function. So here calling function is a of x comma y, and then you can you tell where is the recursive call? Anybody, can you tell where is the recursive call? So here you see in a of x comma y. So in a of x comma y, are you calling any a of x comma y here? No. If here you are calling any a of x comma y, yes. And here also you see a of x comma x minus 1 comma a of x comma y minus 1. So this one we call it as recursive call. So this is the recursive call what we are going to take it. Understood? So this is the recursive call because a of x comma y is again calling a of x comma y minus 1. So this is the recursive call. So if x is equal to 1 and y is equal to 2, that means a of 1 comma 2. So what will be the result? 1 comma 2 both have the values. So then you have to calculate a of x minus 1, that is it will go with 0. Okay, then a of, then you calculate, substitute x and y here and you calculate the value. So that will be the Ackermann's function. So now you come for the program. So this is the program used for Ackermann's function in C. So first you go start with main program. So you start with a main program. So here I am going with x and y value. So x value I am taking for loop. This is for x value. So this is for x. Okay. So x value you are ranging from where to where? So from 0 to 4. 0. So you are ranging from 0 and less than 4. Less than 4 means you are going with 3. So x value will range from 0 to 3 and come for j. So this is for y value for loop. So for y value you are going with j is equal to 0, j less than 4. That means j will also range from 0 to 3. So now you call the function Ackermann of x comma y. So that is %d comma %d. So x we represent it as I and y we represent it as j. So is equal to %d I comma j comma Ackermann's of I comma j. So you have to print the value of Ackermann's of 4 comma 0. So this is the function we are going to take. So Ackermann's of this one is called as a calling function. So here we are going to call a function ACK of 4 comma 0 up to where you have to find 4 comma 0 and you have to find a of 0 comma 0, 0 comma 1, 0 comma 2, 0 comma 3. Next again 1 comma 0, 1 comma 1, 1 comma 2, 1 comma 3. Then you go with 2 comma 0, 2 comma 1, 2 comma 2, 2 comma 3 and finally with 3 values. So 3 row 3 column you go with 0, 1, 2, 3. So now you come for this particular. If m double equals 0, what is m? So here you see Ackermann's of x comma y. So in place of x you are having m, in place of y you are having n. So now you see if x double equals 0. So if x is 0, what you will return? So come for this condition. If x is 0, you are printing y plus 1. So now you see if x is nothing but m equals 0, you are printing y plus 1. What is y? Y value is n. So n value will be n plus 1. Okay. Similarly, if n double equals 0, that means y is equal to 0. What you will print? X minus 1 comma 1. That is m minus 1 comma 1. So similarly, if both are not, so then you return ACK of m minus 1 comma ACK of m comma n minus 1. So m minus 1 comma m comma n minus 1. So here you see this is a Ackermann function. Here you are calling recursively. So this is inside this. So this is recursive. So recursive call, and again this one is recursive call. So these are the two recursive calls we are having. So what this recursive call Ackermann's function is going to do, that you have to see. So what this Ackermann's function is going to do, so it is going to calculate the value of given thing. So as you give 0 comma 0, it is 1, 0 comma 1, when you see the output it will be like this. So similarly you go with finding 4 comma 0. So 4 comma 0 you will get the value as 13. So this is the program what you can go with a Ackermann's function. Understood? So kindly understand this one, it will be very easy. So if x is equal to 0, what is the result? It is y plus 1. If y is equal to 0, what is the value? It is a of x minus 1 comma 1. If both are not 0, it will be x minus 1 comma a of x comma y minus 1. This is the call what you are going to take it. So that is Ackermann's function. So x and y we are taking it as m and n. So if x is equal to 0, y plus 1. So y is nothing but n. So if y is equal to 0, what you will do? You will return m minus 1 comma 1. If both are not 0, what you will return? M minus 1 comma ACK of m comma n minus 1. So this is the Ackermann's function code what you can go through. So have you understood all these programs? Okay, got it up to here. So those who have not yet filled the attendance, kindly fill it here. Okay, so this is up to Ackermann's function. So in today's class, we have gone with programs on recursion, that is prime numbers. So after prime numbers, you've gone with reversing the function. Next, you've gone with Ackermann's function. So this is up to the recursion part. Okay. So I hope you all got understood this particular program. If not, you can use my ID, YouTube ID. I will be uploading that, so you can see in the YouTube also. YouTube also. Okay. Thank you all.